first thing I want to talk about is something I left out in the previous video for sines and cosines. When you have y equals cosine of any angle, or if you have y equals the sine of any angle, and you can have plus a number, the amplitude is the absolute value of the number in front. If here the number was -3, then the amplitude for the first one would be the absolute value of that number, which is 3. If you had 2/3 in front, the amp would be the absolute value of 2/3 or 2/3. That is, it's the number in front without a sign. And that's all you need to know for amplitude. That is, you need to find the sign of an angle and read the number in front. Doesn't matter if there's a number being added. Besides, even if there, quote, is no number being added, you can add 0. Okay, so that's amplitude. It's just the number in front of the sine or cosine without a sign. Now, for the other 4 trig functions, secant, cosecant, and what I'm about to show you now, sine and cosine, they have no amplitude. For one reason, if this is the sine curve, or a portion of the sine curve, the secant curve goes up forever. It goes up forever. In fact, it goes down forever. There is no highest point. There is no lowest point. So that's why that curve doesn't have an amplitude. Same for the reciprocal of cosine, which is secant. They don't have an amplitude. Nor will the the tangent and the cotangent graph, which we're going to talk about now. Y is equal to tan x, and these are the ones you have to know. Sine x, cosine x, secant x, cosecant x, tangent x, and cotangent x. You need to know that one period of a tan x graph, different than sine and cosines, and secant and cosecant, one period of our tangent x graph looks like this. Gets very, very close to the dotted line to the right of pi over 2, negative pi over 2, and very close to the dotted line just before pi over 2. And of course, it repeats this forever and ever and ever. The same pattern. But again, we're just concerned about graphing one period. Okay, so let's do one that's more interesting. One that has phase shifts, etc. And if you notice, that tan graph went up forever, so there's no amplitude. If I ask you the graph y equals tangent of x minus pi, well, not a problem. Since it's understood to be positive tangent graph, it goes like this, goes like that. Graph is done. Get part credit for that. Now, to find the start, you take the angle, which is x minus pi, and you set it equal to negative pi over 2. Since pi over 2 is over 2, when I add pi to both sides, on the left side it's very friendly to add pi, because it cancels out and we see that. But on the right hand side, it'll be better if we write pi with a 2 on the bottom. That way they'll have the same denominator. Well, the numerator is easily found. 2 times pi, or 2 pi, is what goes on the top. So I am going to add 2 pi over 2. And since I'm adding 2 fractions and the denominators are the same, it stays the same. I just add the numerators. Negative 1 pi plus 2 pi. Well, negative 1 plus 2 is 1. 1 pi. Okay, so now we know the start. It's starting at pi over 2. Where does this graph finish? It finishes when the angle is positive pi over 2. So like before, I add plus pi on the left side, but on the right side, I add something that's equivalent to pi, or I write something that's equivalent to pi. What's that? 2 pi over 2. In addition, if the denominators are the same, and they are, we add the tops. And understood, 1 pi plus 2 pi is 3 pi. On the left, the pi's cancel, you just have x. So we know it finishes at 3 pi over 2. Okay, let's get rid of a lot of the side work, like magic. And now let's find out two things. Where that center point is right here, and where the y-axis goes. Remember, pi over 2 is 1 pi over 2. So ignore the pi over 2's. What's in between 1 and 3? 2. If you really don't know that, you add them up and divide by 2. You get 2. In our case, 2 what? 2 pi over 2's. Coincidentally, the 2's cancel out, and you get pi. Okay. So now, since this is positive pi over 2, I know their y-axis is to the left. How far to the left of pi over 2 do you have to go? The answer is immediate. Pi over 2. Well, this distance happens to be pi over 2. So I'm going to go the same distance to the left. And then I'm going to call that my y-axis. And there's your graph. Okay. How about we try to do a negative one? A negative tangent graph. Okay. Suppose you were asked to graph y equals negative 2. Tangent of x plus pi over 2. Well, recall that a regular tan x graph goes it goes this way. Our graph is just upside down. Our graph is going to look like that. Our graph is going to look like that. Except those x values are wrong. In fact, I don't know that those x values are correct. So let's just remove them. Remember, the dotted graph, that's a positive tan x. We have a negative tan x. That is, this graph isn't really here. But everything else is. And what you see this dotted, those dotted lines, those are just their vertical asymptotes. Alright, so one last thing. We don't know the y-axis is in the middle. So I just drew the tan x graph upside down. There it is. Now it starts when the angle is equal to negative pi over 2. I take away pi over 2 from the left. I can take away pi over 2 from the right without changing the way it looks. Why? Because both denominators are the same. In subtraction, if the denominators are the same, keep it and subtract. If you take away 1 pi, and then you take away another 1 pi, well, you took away 2 pi's. And the 2's cancel a 1, so you get negative pi. On the left side, you just have x. Okay, not a problem. It starts at negative pi. Now, I need to erase this and figure out where it finishes. Boom. Okay, it finishes when the angle is pi over 2. Well, if you're adding pi over 2 and you want to get pi over 2, you better start at 0. If you have 0 and you add pi over 2, yes, you will have pi over 2. And if you want to see that, you take away pi over 2 from both sides. I wouldn't even worry about commenting that the denominators are the same. If you have any number and you take away that same number, you get 0. So it finishes at 0. What's in between 0 and negative 1 pi? Negative half pi. And one nice thing is we know where x is 0, which means we know where the y-axis is. And there's the graph. You should label the x-axis. Okay, now let's go and talk about cotangent graphs. Okay, what you need to remember is what a cotangent graph looks like. Cotangent x, that is, you need to know what y equals cotangent x looks like. Cotangent x goes like this, where we have the vertical asymptote at 0 and pi over, and pi. 0 and pi. Okay, cotangent graphs, the angle goes, the start is where the angle is 0, and the finish is where the angle is is pi. It goes from 0 to pi. So if you were asked to graph y is equal to cotangent of x plus 2 pi, well, the first thing you can do is graph it. And cotangent graphs go like this, positive cotangent. For the record, if I ask you to draw a negative cotangent, you should do it like that. And then find the start and the finish by setting x equal to 0, by setting the angle equal to 0, and then the pi. That is, for the start, you set the angle equal to 0. If you take away 2 pi on the left side, then you get what you want, x. And from 0, if you take away 2 pi, you'll get negative 2 pi. Okay, the left, negative 2 pi. Or I should say the start. Now if you want to know the finish is when the angle is equal to pi. If you take away 2 pi, you get what you want, x. If you take away 2 pi from the other side, if you have 1 pi and you take away 2 pi, you have negative 1 pi. So it finishes at negative pi. Now, I want to go pi to the right. Because if you have negative pi and you go pi to the right, you'll end up at 0. I kind of ran out of space. But from negative 2 pi to negative 1 pi is pi. That is, this length is pi. So I really want to go that same length to the right. I kind of ran out of room, but work with me, please. Make believe that was that distance. That is, make believe this distance is the same as that distance. And then I can call that the y-axis. And there's that graph. I want to finish up this video by giving you the table that you must know. The table that talks about the start and the finish for sines for all the functions. For sines and cosines and secants and cosecants and tangent and cotangents. I want to talk about where they start and where they finish. I want to talk about that. Where do they start and where do they finish? And all you have to do is set the angle equal to the starting number. I'm going to put down like 0 and set the angle equal to 2 pi for the end. That's for a sine graph. Cosine graph is the same. secant is the same. Cosecant is the same, which is good. 4 of the 6 are the same. The last 2 are different from the first 4, and unfortunately different from one another. You must know these start and finish points, and then you can do it the way that I've been showing you. Okay, good luck with this. All right, good luck. Thank you.